Hello again. This new video is a accompanying video for the central limit theorem, where we explore that any kind, as I say, any kind of distribution, no matter how wild it is, let's say like that's a distribution for like the probability for getting 0 for a certain event, and then we have the probability for getting 1 for this certain event, probability for getting 2 for that certain event, and probability for getting 3, probability for getting 3 for this certain event. So as you can see, this distribution is not normal at all, but we can turn this into a normal distribution by getting samples. Now, make sure to understand the meaning of the amount of samples you're getting and the sample size. The sample size is how much trials or how much things is inside one sample. So, for example, you would put this distribution into a block box. In that case, a block box is something that you cannot look at inside. It means that if you pick something inside of it, it would all be random. So from this block box, we can get samples from it. Now imagine if once we get a sample, we need to put it back to the block box and randomize it all again. So let's say that we get a sample from that and it landed to be, let's say, 3. And then we got another one and it landed to be 0. And then we got another one and it landed to be 3 again. Because we're returning it, and look at the probability of getting 3 is really quite high. And then we got another sample, and then let's say we got a 3 again. And finally we got the 5th, and then let's say we got a 1. So this entire thing is our sample, and our sample size is 5. We can do this many times as we can, and I suggest doing it more than 30 times. So something elegant would happen if we do it more than 30 times. So if we do number of samples to be 30 of sample size each to be 5, we're going to have something quite magnificent. And if you've seen in the other video, what happens is once you get the mean, let's call this the sample, the mean of each sample, the distribution of those means, as we've seen in the last video, would approximate a normal curve. So this normal curve is produced by taking a sample size of 5 from a block box using this distribution, and we had 30 samples, so we produce a normal curve like that. Now, as we talk about the interesting property of the mean of the sample distribution, the mean which is right here, the mean of the means, or the mean of the sample distribution, is equal to the mean of our population. So no matter how weird the population distribution is, the mean of the sampling, the mean of the sampling distribution is equal to the mean of the population. What I mean by the mean of the population is the mean of this distribution. If we know the probability, the y-axis, if we know the y-axis for each one, then we can calculate for the mean. As I told you before, it's just the sum of xi's times the probability of that particular statistic, and that would be equal to the mean. That's another alternate way that you can get to mean. So anyway, we've already talked about that. Another important thing about this sampling distribution, which would always be a normal curve given that the number of samples is more than 30. Another interesting thing about it is the standard deviation, or the standard error. The standard error of the means of this sampling distribution is equal to the standard deviation of the population, alright, divided by the square root, take note, the square root of the number of samples. So in this case, since the number of samples is 50, if we know how to calculate for the population standard deviation, then it would just be equal to the population standard deviation over the square root of 50. Alright, so that's the end of the video. Thanks for watching. See you again.